Hey again, folks. One more short problem for today. This one is testing our knowledge of dimensional analysis, as well as the ability to set up and solve a system of equations. Let's get started. The first equation in our system is going to relate those average energy expenditure rates to the total amount of energy that this student uses per day. Remember that the units of watts are joules per second. So if it helps, you can rewrite this first equation using those units instead, like this. The second equation will relate the two different times to the total amount of time in a day. However, hours is not a helpful quantity here. We can't take joules per second and multiply it by hours to get joules out. What we'll need to do is convert 24 hours to seconds in order to make that multiplication consistent. So if we take 24 hours and multiply it by 60 minutes per hour to eliminate the hours units, and then multiply that by 60 seconds per minute to eliminate the minutes units, we'll get the final result in seconds. Now we can begin solving the system. Let's grab this second equation here at the bottom. Our goal is to figure out T1. So let's move that quantity over to the right-hand side and get an expression for T2. If we go back to that first equation in our system that we had previously, we're going to plug this new time expression in where T2 lives, right here. Here's what that looks like. I'll distribute this 100 joules per second quantity into this nearby parentheses and separate the results so that it's clear to see what's going on. In the second term here, we're taking 100 joules per second times 86,400 seconds, and that will result in this quantity of joules. That's a pretty big number, so let's make it look nice and write it using scientific notation like all the other values here. If we move that amount of joules over to the right-hand side, we'll have all the joules on one side and all the joules per seconds on the other. At that point, we can subtract like terms on both sides, and what I'll do here on the right is hang on to an extra significant figure to ensure that we don't make any rounding errors on the way to the answer. Let's divide both sides by what's in the parentheses here on the left, and in doing so, our joules units will cancel, and we'll be left with the result for T1 in seconds. Now, we don't normally count the lengths of our days in seconds, so let's convert this value back to hours, which is a bit more reasonable. It's essentially the same process as before, but now our conversion factors are flipped. So we'll end up canceling out seconds and then canceling out minutes to go back to hours. And with that done, here's our final result, minus the extra significant figure that we carried along the way for accuracy. Thanks for watching, everyone. Take care.